All right, so on number one, what's one of the transformations we can write down? Yes? Good, x-axis reflection. Doesn't matter the order, as long as we get them all in there. So x-axis reflection. All right, that's the negative in front. Next one. Yeah. Good. Yeah, good. All right, so the 5, that's going to do a horizontal shrink by 1/5. Okay, remember, inside does the opposite, and it's multiplying by 5. That means it's stretching, but we have to do the opposite to make it shrink. And to make it shrink, you got to turn it into a fraction, which would be 1/5. All right, so horizontal shrink by 1/5. 1/5. All right, and then one more? Yeah. Yeah, up 3, that's the plus 3, up 3. All right, and that's all of them. That's all 3. All right, number 2. All right, so what's one of the transformations? Yes. Okay, good. Vertical stretch. That's the 2 on the outside. Vertical stretch by 2. Another one? Good. The negative in front, that's going to do an x-axis reflection, just like the one above it. Okay, another one. Yeah. Good. Left 1, that's the plus 1 inside. We do the opposite, so it's going to go left 1. Yes. Good. Down 7, the minus 7 at the end, that moves it up and down. Since it's negative, it's going to go down 7. All right, so now what we're going to do is we're going to do the reverse. All right, so now they give us the transformations, the descriptions, and then we're going to put it into a function or an equation. So you want to remember everything that's vertical, that's up, down, vertical stretch, vertical shrink, that's all stuff that has to stay on the outside of the parentheses. Anything that deals with horizontal, so that's left or right movement, horizontal stretch, horizontal shrink, that deals with inside the parentheses. All right. All right, so they want us to write this function, this general function f. So kind of look at how 1 and 2 were written with that f in there. All right, so y equals, okay, we'll just throw this f in there, and we'll throw open parentheses. All right, so we have a vertical shrink of 2/3. So because it's vertical, it's going to be on the outside, and that means the function's being multiplied by 2/3. So that 2/3 is going to be on the outside in front of the f. Okay, that gives us the vertical shrink. And then horizontal shift right 7. So remember, left and right stay on the inside of the parentheses. And since it says go to the right 7, that's in the positive direction, we change the sign to a negative. So on the inside, we're going to write x minus 7. All right, and that's it. There's just 2 transformations on this that they gave us. So again, we can see, after you write it, just check and make sure that it does what it's described as between right 7 and then a vertical shrink of 2/3. All right, and then let's go ahead and do number 4. Same way, just a general function f. Okay, so y equals, and then we'll just throw this f in there somewhere. All right, so here we have a horizontal shrink of a half, a reflection over the x-axis, and then vertical shift up 6. All right, so the horizontal shrink, since it's horizontal, it has to go on the inside, and it has to do the opposite when we put it into the parentheses. So the opposite of a half, or the reciprocal of a half, would be 2. So we're going to multiply the x's by 2. Okay, the x by 2. There's no left or right transformation, so we can close the parentheses. Right? So hopefully you see where the horizontal shrink is coming in. Okay, it's that 2 being multiplied to the x has to do with the opposite, or the reciprocal. All right, then we have a reflection over the x-axis, and so we want to remember where the negative goes. That goes on the outside in front. Remember, if it's a y-axis reflection, then the x on the inside is has a negative on it. It's being multiplied by the negative. And then vertical shift up 6, so then it's going to be plus 6 at the end. All right, number 5 wants us to write a specific function with x squared in it. All right, so this is a quadratic function. So we know we're going to have an exponent 2 in our equation. So again, we can start it off the same way. Here, I know I'm going to have a square on it. All right, so I have a vertical stretch of 4, a reflection over the y-axis, and a vertical shift down 2. So the stretch of 4, vertical, that's on the outside, so that's going to go in front. The reflection over the y-axis, that means the x on the inside of the parentheses has to be multiplied by a negative. So I have a negative x. And then down 2 would be minus 2 at the end. All right, so again, once you write it, just check and verify that it does what it says. If it doesn't, then you're going to have to just switch something. Okay, maybe it's a sign. Okay, vertical stretch 4, y-axis reflection down 2. Because this is asking us to write a specific function now, an x squared function. Okay, so remember there's 8 specific functions, parent functions that we talked about. Okay, so now we can get into specific ones. If they don't give you a specific one, then you're just using f as a general function. All right, so let's do number 6. So now they want us to write a specific function that's absolute value. Right. So we know we have absolute value bars in it. All right, so here we're going to go left 4, reflection over the x-axis, and then up 8. So see where each of those 3 things go. See if you can figure that out. Okay, going left 4, reflection over the x-axis, up 8. All right, so left 4, that means it's going in the negative direction. So we switch it to put it on the inside of the parentheses. So it should be x plus 4. All right, so that means it's going left 4. Reflection over the x-axis means that we have to have a negative in front. Up 8, that means it's going to be a plus 8 at the end. All right, 7. Given the parent function cube root x. Cube root x. Let's go ahead and write the equation for that. So y equals. Okay, we know we're going to have a cube root. All right, we have a reflection over the y-axis and down 1. Right, so if it's reflecting over the y-axis, we have to have a negative on the inside being multiplied to the x. Down 1, minus 1 at the end. All right, number 8. Given the parent function f of x equals absolute value x, create a function that would have a range of 4 to infinity. All right, so the first thing that you would want to do on this kind of a problem is sketch out the parent function. And so what would the shape of the parent function look like? What's the shape? What is it? No. It's a V. Absolute value, the letter V is in it. Absolute value. Okay. So if we sketch this out real quick, this is just the parent function. We know it's right there. The two rays, the vertex of the absolute value, meet at the origin. So given this, what's the range of the parent function? What would the range be? Yes?
0 plus infinity.
Good. 0 to infinity. All right. So if this range, which is this equation right here, has a range of 0 to infinity, what would I have to do to that graph to make it 4 to infinity? Yeah. No. You don't want to flip it sideways. Yeah. No. Yeah. Up 4. Yeah, we want to move it up 4. So think of your horizontal, remember range, we go horizontal lines. Okay, what horizontal lines are going to intersect the graph? It doesn't hit down here. It starts here at 0 and goes to infinity. I want it to start at 4 now. Well, if I want to start it at 4 and go to infinity, I got to take this whole graph and shift it up 4 units. All right, so the graph would basically be right there. Okay, I shifted it up 4 units. So now I know what the graph looks like. Now all I have to do is put that, what I just did, and put it into an equation. Well, what is the plus 4? If it says it shifted up 4, where do I put that in the equation? I put it at the end, outside, yeah. Because the outside number moves the graph up and down. So then my equation would be y equals absolute value x, and then just a plus 4. This has a range of 4 to infinity. All right, so let's do number 9. Okay, again, we'll just stay with the absolute value. Okay, again, we'll start with our parent function graph. And now we want the range to start at negative infinity and go to 8. All right, so here's our parent function. Again, the range is starting at 0 to infinity. So what would I have to do to get it to start at negative infinity? Yeah. Good. So we have to flip it over so negative infinity comes first. So we take this and flip it over so it's pointing down now. So negative infinity hits us first. And to do that, that's called an x-axis reflection. Okay. So we reflected it so it starts at negative infinity. Okay, so now I flipped it over. The range now is negative infinity to 0. Well, how do I get it from negative infinity to 8? Yeah. Yeah, good. So then I would shift it up 8. So I flipped it over. I did an x-axis reflection. Now I'm going to shift the whole thing up 8 units. All right, so that's basically what the new graph looks like. Okay, so the highest point now is 8. So now this has a range from negative 3 to 8. So now all I just have to do is put those two things that we just did into my equation. So the range is negative 3 to 8. So the first thing we did was we flipped it over the x-axis. Okay, so it starts at negative infinity. That means it has to have a negative in front. That's the x-axis reflection. Then somebody said, well, let's just shift it all up 8 units. So then we have to do a plus 8 at the end. All right, number 10. Given this general parent function graph, similar to one that we did on the homework the other day, what I want you to do is, instead of making an XY table and plotting points, I want to see if you can do all 3 of these transformations for all 7 points without a table. Okay? So basically, you just take your finger, okay? Start with 1 point. Okay, so we can start at this point right here. There's 7 of them. Okay? So just take one of the points, and you're just going to do exactly what this says. All 3 transformations. Okay, you're going to do the first one, then the second one, and then the third one, and then you'll take your pen and plot the new dot. Okay? So you're first going to shift it left 2, then you're going to reflect it over the x-axis, then you're going to shift it down 3, and then plot it. And you'll do that for all the points, and then you should be able to just connect them. Right, so sometimes it's easier to just plot the points using your finger to move it around than making an XY table each time. Okay, the XY table, generally you use it when you have a general function like this if there's stretches and shrinks, because it's really hard to multiply in your head and then move things around left, right, up, and down. If you don't have any vertical stretches and shrinks, then it's easier to just move the points with your finger. And there was a question on the quiz yesterday that had to do with this. It was easy to just move it around. You could have plotted the points. All right, so this is what your graph should look like. Again, all you're doing is taking a point. Okay, if I start here, you're going to go left 2, then reflect it over the x-axis. But if it's on the x-axis, that means it can't move off the x-axis. There's nowhere to move it. So then we can just move it down 3. 1, 2, 3. There you go. Okay, and just take the next point. Left 2. Now you're going to reflect it over the x-axis. It's 3 units below the x-axis. So now we have to go 3 units above the x-axis. That flips it up here. Now you're going to shift it down 3 units. 1, 2, 3. Right there. Okay, same thing for each one. Move it left 3, reflect it, and then go down 3. All right, then the equation that we're going to write for this, y equals, and then we have an f. All right, left 2, that means it went in the negative direction, so we changed the sign to plus 2. A reflection over the x-axis means that we have to lead off with a negative in front. Down 3, we have a minus 3 again. All right, number 11, what's the domain of all absolute value functions? Yes. Perfect. Okay. So the reason why, again, this is why it's important to understand what the shapes look like. Okay, so that's an absolute value function. Its domain, if we go left to right, will be negative infinity to positive infinity. Well, what if I move it? Let's say I move it over here. It's still negative infinity to positive infinity. Well, what if I flip it and move it over here? it's still negative infinity to positive infinity. So it doesn't matter where it gets moved, the domain will always be the same. The range will change, but the domain won't. Yes?
How do you know that it's going that way?
Because the shape of an absolute value is a V. Because in unit 1.3, we plotted 5 points from -2 to +2. Okay, for x, we plugged them into the parent function and found the y values, and it all plots into a V. All right, let's see. And then the parent function for all absolute value functions, y equals absolute value x. Right, so again, we came up with all the shapes in unit 1.3. All right, so then 13 is an absolute value function. What I want you to do is go ahead and describe the transformations. Make an XY table. Come up with your parent function values, and then apply the transformations and graph it. And then go ahead and give the range. We already know what the domain is because it's absolute value. We already stated what it is. It's negative infinity to positive infinity. So I'm asking what the range is now. All right, so again, when we're plotting our points for our parent function, you can use -1, 0, and 1 for x. Okay, so you're just taking those values and plugging them in to the parent function, taking the absolute value. So the absolute value of -1 is 1, the absolute value of 0 is 0, and the absolute value of 1 is 1. All right, now we can apply the transformation to these values. All right, x plus 2, since it's on the inside, affects the x values. We do the opposite. Some of you forgot to do that on the quiz. All right, the outside stuff affects the y values, so we'll multiply by -y, and then add 5. Multiply by -1, and then add 5. All right, so our new values looks like -3, -2, -1. -1 plus 5 is 4, and then 5, and then 4, 8. All right, then plot those points. -3, 4, -2, 5, -1. All right, so this is a reflected absolute value graph. It's pointing down now. Make sure it looks like a V and not a U going down. Okay. U's are different than V's. Even though they look similar, they're different. A U is a quadratic. A V is an absolute value. All right, and then the range looks like it's going to be -infinity all the way up to +5.